Question 5 gives you aqueous sodium bromide reacting with chlorine, forming sodium chloride and bromine. Now this is a displacement reaction also, but of group 7 elements. Okay, so what would I observe when chlorine is bubbled through sodium bromide? I notice that bromine comes out. And we know the color of bromine, it's brown. Sodium bromide is colorless, bromine is brown. Colorless solution turns brown. Answer. Okay, next, bromine oxidizes aqueous potassium iodide to iodine. So I want bromine and potassium iodide. I need to write an ionic equation. So I need to use ions. Bromine, diatomic, is not ionic here, plus potassium iodide, so there's iodide ions, gives me bromide ion because it changes, plus iodine, which is displaced. Now let's balance this. So I put a 2 here, I put a 2 here, and we're done. Now I want to explain why aqueous iodide ions are oxidized in terms of oxidation number. Okay, so we notice that here the oxidation number is actually -1, and in here in I2 the oxidation number is 0. So let's write it down, -1, 0. Okay, this is not the answer yet. How do we write the answer? There is a what? Increase or decrease? -1 turns to 0. So there is an increase in oxidation states. I write short, you write long, from -1 to 0 when I minus turns to I2. Okay. Now in the same way, I want to talk about an oxidizing agent. An oxidizing agent, in this case, we've got a nice equation, gives oxygen to the other fella. So which fella gave away an oxygen? It's copper to oxide. So very simple. Copper to oxide gave away oxygen. Okay. Now solution X, moving on, is an oxidizing agent. So how would I describe the observations when aqueous potassium iodide and potassium manganate are added separately to this? Potassium iodide is a reducing agent. If you forgot, telling you. So if this is a Ra, there will be a change. We mentioned it above. Iodide ions turn to iodine, but how do we write the change? Color of aqueous potassium iodide changes from colorless to brown. Okay, iodine comes out of solution. Next, potassium manganate is an oxidizing agent. Will I expect a change? No. So potassium manganate is purple, so color of aqueous potassium manganate remains, please don't tell me the same, remains purple. Okay, and that's question 5.